So we're starting today's section 6.1. This is called the Law of Sines. I'm going to do 6.1 today, and I'm going to do 6.2 tomorrow. All right, and then we're going to take Wednesday, Thursday to practice. What is the date right now of your 6.1 homework? When's it due? Oh, I didn't even publish it yet? Okay, perfect. I'm going to make all of your homework, 6.1 and 6.2, just due on Thursday. So you guys will have, the next few days to do it, to practice. A couple days, do some work, however you want to do it. You will need a calculator. If you guys don't have a calculator, you're not going to be able to complete all of the problems. It doesn't have to be super fancy graphing. Just a normal calculator is fine. But you guys do need one. It's best to have it in class with you every day. So if you have questions about your calculator, I can try and help you answer them. But you guys will need them. All right. We're going to talk today about law of sines, tomorrow law of cosines. And we're going to talk about two different formulas for area. Heron's formula and area of an oblique triangle. I will give you all four of those formulas on your quiz on Friday. So you don't have to memorize any of the formulas. Yeah.
Are they going to be given to us on the test as well?
Yep. Mm-hmm. Yeah. So you guys will have the formulas in front of you. I promise you. You don't have to ask me that 100 times. I promise you will get them. I just need you guys to know how to use them. All right. We're going to talk today, this week, about oblique triangles. What are the triangles that you're most likely, what are you guys so used to seeing? Right triangles, right? Pythagorean theorem's got a right angle. None of these triangles are right triangles. That's why you can't use the Pythagorean theorem. Just talking about notation of things. This should be a review. When we talk about side lengths versus angles, angles are always written with capital letters, right? So if I say C equals 59 degrees, okay, there's two ways that you know that that's an angle. One, because there's a what sign with it? A degree, good. And two, because it's a capital letter. Side lengths are always written with lowercase letters. You guys see that? Yeah. Okay, that's a good thing to know because a lot of times they're not going to give you a picture. They'll tell you something about two sides and an angle, and then you have to draw. You don't have to, but sometimes it's easier. Another thing I want to remind you of is if you notice, hopefully you guys, this is a reminder, not just brand new information. Do you see how side C is across from angle C? And side A is across from angle A. And B is across from B. You guys see that? So when they give you information about two sides and an angle, or two angles and a side something, you should be able to draw the picture because the angle and its corresponding side are across from each other. All right, everybody got that? Units of measurement are going to be really important. If something is feet, you need to have feet or feet squared. If it says to round, you guys need to be able to know how to round. Those sorts of things, that's where you get little points taken off here and there. All right, to solve an oblique triangle. Again, we're not doing any proofs, so you guys don't have to worry about this. These are just the geometric theorems about information that's given. Two angles and a side, two sides and an angle, side, angle, side, and three sides. Notice, guys, the order matters. This angle, angle, side means there's two angles and a side. This angle, side, angle, do you see how the side is in between? Do you see here, this is side, angle, side, what's in between? The angle, okay? Again, you're not going to have to prove anything with it. I'm just reminding you. All right, here is the law of sines. All it is, guys, is a proportion. Side A corresponds with sine A. Side A corresponds with angle A. That should just be, you guys should understand that. You should know that. Notice what's written on top? Side lengths or angles? Side lengths. How do you know there's side lengths? Because they're lowercase. Good. You can also solve this formula with the angle on top. You can, either way, it's perfectly fine. I generally do it how it's written in red. I don't know why. I just like sine of the angle on top. As long as you keep angles together and sides together, you guys are fine. All right, but here's your law of sines. Again, you will be given this on your quiz. The law of sines. Oh, I didn't realize this was the next slide. I'm sorry. It can be written in the reciprocal form like I just said. Just as long as you keep A together, B together, C together, and then you keep angles on top, sides on the bottom, or vice versa. It'll work fine. So let's look at this. Sometimes they'll give you a triangle, sometimes they will not. You don't need the picture. But when they tell you to solve a triangle, you're finding everything that's missing. So in this case, I am missing angle A, right? I'm missing side C, and I'm missing side A. Do you guys agree with that? Okay, so we're going to use a little common sense here before we start anything crazy. Do I already know how to find angle A?
Yeah.
How come?
Because every triangle is 180.
Every triangle has 180 degrees inside. Well, I already have two angle lengths. I have 102.3 and I have 28.7. You guys agree with me? So just add those up. What's 102.3 and 28.7?
131
131 what?
degrees.
Okay. So angle A is 131 degrees. So you guys would tell me.
No, that's 102 added up with 20.
Oh, my bad. You're right. I'm sorry. I don't know why yeah. Now I subtract from 180. Monday morning. 131, thank you. Minus 180 is how much?
49.
49. Thank you. So angle A is 49 degrees. So one of your answers, angle A, is 49 degrees. Do you guys see how I wrote the degree symbol? Very important. Take a point or two off if you don't. So now I have to find the other sides. Guys, this is not a right triangle. I can't use the Pythagorean theorem. So we're going to use the law of sines. Do I now have a side length and its corresponding angle? Do I have those measurements? What do I have? I have side B and I have angle B. Does everybody see that? The law of sines, you'll always be able to use a side and its corresponding angle length. Now again, it doesn't matter. You can do the angle on top or the side on top. I like to do the angle on top. So I'm just going to say sine of 28.7 over. How long is the side? 27.4. Now I have to solve for side A and side C. Doesn't matter which one you solve for. You could do either one. What do you guys want to solve for?
C.
Okay, we'll solve for C. So I don't know what C is. I'm looking for side C, so it's going to go on the bottom, right? You guys agree? Okay, so what is the corresponding angle that goes with side C? 102.3. So 102.3 degrees. That right there is the geometry pre-calc part of this lesson. Because now I have a proportion set up, do I not? How do you guys solve a proportion? You cross multiply. So I'm going to say 102.3 times 27.4. And I get what?
What is it? Isn't it sine?
Sine 102.3.
Oh my gosh, guys, what is wrong with me today?
Calculate sine first.
Yes. No, you don't want to calculate sine first. Sorry. Oh, thank you. Nat. Sine of 102.3. Okay. So now we're going to cross multiply. So in your calculators, guys, literally 27.4 times the sine of 102.3. Don't even hit enter. Don't worry about that. Just leave it like this. Write it like this. Cross multiply. And then hit C. You don't even do it yet. Just write it out. Watch what I'm doing, Gabe. Do you see how I just wrote them? Do you see how I just wrote what I cross multiplied? Okay. Don't even worry about calculating, guys, till the very end, because if not, you'll drive yourself crazy with rounding. How do I get C all by itself?
Divide.
I would divide by what?
Sine.
The sine of 28.7 divided by sine 28.7. Now, go ahead and do it in your calculator. It's easier this way. If you guys don't, you're going to round and round and round, and every time you round, you get further and further away from the correct answer. So in your calculators, just like you see it, 27.4 times the sine of 102.3 divided by the sine of 28.7.
I got a negative 55.7.
Okay, hold on. That's good that you just got that. Hang on. 55 point, let's say 75. And what are we talking about? Feet?
Yeah.
Okay, now, if you got a negative, check your calculator mode.
10 degrees.
Are you sure?
Yes.
All right, now, okay, we've solved for side C. And we got 55.75 feet, right? Remember, degree symbol and your unit of measurement is important. Now, what's the piece that we're missing? Okay, we got to find out. We already found C. Now, you can go back and use the same corresponding angle and side that you just found. You can use B, right? Or I can now use side C and angle C, correct? Because you have both of those things. Doesn't matter. I always go back to what was given at the very beginning. Since B was given to me, that's what I'm going to use. So I'm going to say sine of 28.7 over the side length is 27.4, correct? Equals, now I'm trying to find side A. So what goes on top? Sine of 49 over side A. And again, you're going to cross multiply. So you have 27.4 times the sine of 49 equals the sine of 28.7 times A. How do you get A all by itself? Divide by the sine of 28.7. Take a second. Make sure you get your fingers correct with your calculator. So 27.4 times the sine of 49 divided by what? 28.7. What'd y'all get? 43.06 feet. That's what I got too. So side A is 43.06 feet. And you solved the triangle. So guys, can I give you 15 of these to do on a quiz? No, it's going to take too long. Are there a bunch of areas that you can make really silly mistakes because you input something incorrectly, because you hit the wrong button, because you weren't paying attention to decimal places? Yes, so just make sure you guys take your time. All right. Now, there is something called the ambiguous case. You will, at some point, work something out in your calculator, and when you hit, you go through the whole thing, sine of this divided by this, and it says error. If you get an error message in your calculator, my first suggestion is to redo it in your calculator just to make sure. But if you do get an error message and you're sure you're putting everything in correctly, that means no triangle exists. That is a possibility. Don't get upset. Or it could be like we just did, where one triangle exists. But there are cases where there's like a hidden triangle. And I'm going to show you there's a little trick to just figure out if there's a second triangle. It's not anything crazy hard. It's just a couple little extra math calculations. But you could come out with two distinct triangles. And this is called the ambiguous case. This is when you have two sides and one angle given. It could possibly happen, okay? So let's look here. Got a word problem. Does everybody see? They drew the picture for you. It says the pole tilts towards the sun at an angle of 8 degrees from the vertical and casts a 22-foot shadow. The angle of elevation from the tip of the shadow of the pole is 43 degrees. How tall is the pole? Thankfully, they drew us the picture, so let's just look. What am I looking for? How tall is the pole? What am I looking for? A, I'm looking for height. So let's think about what we have here. I have 43 degrees here. Great. I don't know what A is. Do I know how big this angle is right here?
98.
What is it?
98.
How'd you get 98?
90 plus 8.
Good. It's more than vertical, is what they told us. It's like leaning for whatever reason, so they got to fix it. So I'm looking for side A. I'm looking for this piece right here. How would I begin to do this? First thing I'm going to look at is, do I have an angle and its corresponding side to use as my law of sines proportion? No. But can I figure out this missing angle?
Yes.
How can I figure out this missing angle right here?
98 plus 40.
Okay, 98 plus 43 gives me how much?
141.
141? And then how do I figure out what C is?
180 minus 141.
180 minus 141 is how much?
39.
39. So angle C is 39 degrees. Have I answered the question? No, I want to know how tall A is. I'm not solving the whole triangle. I just want to know how long A is. So what is the side now and the corresponding angle that I have to use as a proportion? I have C. I have angle C, so I have the sine of 39 over how long is side C? 22 equals what over what? Sine 43, good, over A, because I don't know what A is, and that's what I'm trying to figure out. Did they ask me to find C? No, but I knew I had to because I need an angle and its corresponding side in order to use the law of sines. So now, guys, we just cross multiply. I have 22 times the sine of 43 equals A times the sine of 39. Agreed? Okay, divide both sides by what? Sine of 39, good job. And A equals how much? About 23 point what? 84. What are we talking about? Feet. Okay. Are you guys getting that? Do we agree? Okay. Did they ask me for any other information? No, they just want to know how long or how tall that pole was. Good job. 180. There are 180 degrees in a whole triangle, right, Kaylee? So in order to use the law of sines, we need to have a side length and its corresponding angle. So before we did this, I knew that angle B was 98, but I don't know how long side B is. I knew that angle A was 43 degrees, but I didn't know how long side A was. I knew how long C was, but I didn't know what the angle measure was. But since I already had two of the angles, you can add up those two and subtract from 180, and that leftover amount will be that missing angle.
Okay.
You can always do that. When you have two angles, you can always add up and divide. All right, so let's move along. We just talked about the ambiguous case. Let's look here. All right, for the triangle, find the remaining sides. Now, this already tells you there's one solution, but we're going to go through the process of seeing if there's two solutions, just so you guys get in the habit of doing this. This only happens with the law of sines. When we go to solve triangles and they tell you use law of cosines, you can't have two triangles. So when I look at this, I'm going to say, okay, what do I have and what am I missing? What am I solving for? What are the three things I'm going to solve for?
Angle B.
Angle B, angle C, and side C. Okay, perfect. Now, when you are doing these, you guys should have in your mind, ooh, there is a possibility that there's two triangles, so I have to make sure. I got to check. We're going to do that. So I'm going to set this up, and I'm going to say, okay, I'm going to solve for triangle 1, and then there might possibly be triangle 2. I'm just going to get in my mind that that could happen. Do I have a side length and its corresponding angle that I can use for my law of sines? Right here, right, A? Okay, so I'm going to do some calculations here. I have the sine of 42 over 22. Agreed? All right, so what side and angle should we now solve for? B? Okay. Do I know what B is? Okay. I know the side is 12. Do you guys see how this one's a little different from what we just did? Yeah? Does everybody see how this is a little different? Why is this one a little different? Right. This is we're actually going to solve for the angle measure here. So we're going to do a little bit extra in our calculator, but it's no big deal. We're still going to solve the exact same way. Cross multiply. So 22 times the sine of B equals 12 times the sine of 42. Agreed? Okay. Divide both sides by 22. And I get the sine of B is. Do that in your calculator, guys. Are freaking out a little bit. You're like, wait a second. I got 0.3649. What? Guys, does that make sense that your angle measure, one of the angles is 42 and the other angle measure is 0.3649? You did not figure out what the angle measure is. You found out what the sine of the angle measure is. Look at your calculators. Do you guys see your trig function sine? Do you see above it there's a little sine -1? Hit second and sine. So little sine -1 should come up. Looks like this. Right? And then put in 0.3649. Put at least 4 decimals in. So 0.3649. And you guys should get that angle B is how much? 21.40 degrees. All right. Does that make more sense? Yes. Okay. So what we're going to write down now is we found that angle A, we already knew was 42 degrees, right? They told us that. We just found that angle B was 21.40 degrees. Yeah? So, guys, now if you're trying to find angle C, how would you find angle C? What would you do? I'd add up 42 and 21.4, right? So 42 plus 21.4. And I get what?
Oh, wait, 63.40.
I get 63.40. And then how do I find out what angle C is? I'm going to subtract 180 minus 63.4, right? And I get 116.60, we can say, degrees. All right, now we can find the other side lengths, and we will in a second. But how you figure out if there is a second triangle, okay? If there was a second triangle, the given angle would still be in that triangle. So the given angle was 42 degrees, correct? So, in order to see if there is a second triangle, and we're going to do a bunch of these, so don't get confused. I just found angle B, correct? We're going to find the supplement to angle B. What's the supplement mean? 180 minus. So I'm going to say, what is the supplement to angle B? I'm going to say 180 minus 21.4. What is 180 minus 21.4? 158.6 degrees. So if there was a second triangle, angle B would be 158.6. So how would you guys figure out angle C in the second triangle? No, what did we do in the first one? We took the 2, added up, and subtracted from 180. Okay, so we do the same thing. I'm going to say 42 plus 158.6 equals 200.6. How many degrees are in a triangle? 180. Are there enough degrees left over for a third angle? No. So is there a second triangle here? No. What you're going to do is you're going to take the given angle, right? You're going to say if the given angle is in triangle 1, then it's got to be in triangle 2. So once you find that second angle, then you find the supplement to that angle. If those two add up and are less than 180, then you're like, ooh, there is a hidden second triangle. If I take those two and add it up and it's more than 180, then there's not a second triangle. Yes, sir?
So you can find the supplement of any other angle besides angle? Doesn't matter which one?
Correct. Yeah, it doesn't have to be alphabetically A, B, C. That's a good question. They might give you angle B. It's just whatever angle you find next. Just find the supplement. Yeah. So now, guys, we're going to go ahead and we can finish this triangle. I know there's only one. So I have all 3 angles. Now I got to find some sides, right? I have to find side what? I got to find side C. I can use whatever angle and its corresponding side that I have. I have 2 of those now. I'm going to use what was given at the very beginning. So I'm going to say the sine of 42 over 22 equals sine of what? Sine of 116.60 over little c. We cross multiply. Again, do your rounding and division and all that stuff at the very end, so your answer is really close to as exact as possible. So sine 42 divided by the sine of 42 divided by the sine of 42. So side C is about how much?
29.39.
What are you guys getting?
28.47.
Okay, so C is 29.40-ish, and we're talking about what? Inches. So we solved the triangle. Guys, if you want another way that you can look to see if you're on the right track, the longest side should be across from the longest or biggest angle, right? The smallest side should be across from the smallest angle. They're all in proportion with each other. So just check. 116 is my biggest angle. Is 29.4 my longest side? Yeah, so you're good to go. But we're always going to check to see if there's a second triangle. Let's look at this one. Now, again, I see that this says there's no triangle. That's fine. We're going to go through this. Just say they didn't give me this picture. Yes, sir.
So from now on, for every question we get,
For law of sines, you want to check.
you want to check for, like, do the supplement?
It's just one extra step to check the supplement.
And if there's two, we solve for both of them.
Yep. We're going to do one in 1 second. Okay, let's just pretend they didn't give me that picture. I can look at this and I can see, I can already set up a proportion for law of sines because did they give me a side length and its corresponding angle?
Yeah.
Okay, so I'm just going to write that down. I'm going to say sine A over side A. Now, I don't know anything about C, but I do know a side length for B, correct? So I'm going to put 25 on the bottom, and I'm going to solve for angle B. And when I do this, am I going to find the exact value of B? No, it's going to give me the sine of B. This is where I have to do my second sine. So again, guys, follow what we've been doing. 15 times the sine of B equals 25 times the sine of 85. Now what do? Divide by 15. So you get the sine of B is, let's do this, 25 times the sine of 85 divided by 15, 1.660. Now, does that make sense that that's my angle measure? No, that's the sine of B. So in my calculator, I'm going to hit second sine. Some of you can just do second sine, second answer. If you don't want to do that, that's fine. Just put in second sine and then 1 point. Yes, ma'am. 1.660. So do that in your calculator. Second sine 1.660. And you guys get?
Error.
Oh, error. Whoops, I didn't spell error right. I had an error in my spelling. What did I tell you guys? What happens when you do all of the calculations and then you get an error message?
No triangle.
There is no triangle. The information that they give you does not form a triangle. That is okay. You could work these problems out. They just give you random numbers and it does not create a triangle. So if you get your error message in your calculator, don't come up to me and be like, oh, Miss Meadows, you made a mistake. No, it's okay. There's no triangle formed. Sound good? Yep. Yeah, that would just be the answer. All right, I'm going to get through all of this today, so I give you guys tomorrow to just work, because I have this example and then area, and area is super simple. But again, when you have law of sines, you need to check for that second triangle. Could be the ambiguous case. This is telling you there is one, but this is how I want you guys to approach this. Look, no pictures given, right? But I do have a side and its corresponding angle measure, correct? Okay, so I'm going to I'm just going to get it set up. But I have two triangles. In each triangle, what's the given angle? 20.5, okay? If two triangles exist in both of those triangles, angle A is going to be 20.5 degrees. Now, Gabe asked a good question a second ago. Do you solve for, you guys, they're going to give you an angle. Don't worry about what letter it is. Don't always solve for B. It just matters, solve for the second one. All right, so I'm going to now set this up, and I'm going to solve here for the second angle. So I'm going to solve for B, and then I'll figure out what B is over there if there is one. So set up your proportion. I have 20.5, the sine, sorry, sine of 20.5 divided by what? 12 equals the sine of B, I don't know what it is, divided by 31. Set up our law of sines, our proportions. So I'm going to cross multiply 12 times the sine of B equals 31 times the sine of 20.5, correct? Divide both sides by 12. So I get the sine of B is how much? Y'all getting 0.9047?
Yeah.
Okay. So hit second sine, second answer. 64.78.
What was this one again?
0.9047. I got 64.78 degrees. Agreed?
Yeah.
Okay, so in the first triangle, I got that angle B was 64.78 degrees. Now let's figure out if there is a hidden second triangle. How do I do that?
Subtract by 1.
I'm going to subtract by 180. I'm going to find the supplement. So, whoops, 180 minus 64.78. Tell me what you guys get. 115.22, say?
Yeah.
Okay. All right. That's doable. That's conceivable. So let's go back to triangle 1. Let's go back to triangle 1. How would I find angle C?
Same thing. Oh, it's 180, add them up. And
Okay, add them up. So 20.5 plus 64.78 is 85.28, right? And then say 180 minus 94.72 degrees. Now, if there is a second triangle, I would add 20.5 plus 115.22, right? And I get what? 135.72. Can I do 180 minus here?
Yeah.
What's 180 minus
44.
135.72? And I get what?
44.28.
So how many triangles are here, guys? Do you see how you find that little missing, the hidden? We'll not call it missing, we'll call it hidden. Take the given, right? Solve for an angle. Find the supplement of that. When you add the two together, if it's less than 180, then you know, ooh, there's a second triangle. Now I would go about finding all the missing sides, just using your law of sines. Gabe, question.
So you can't find the angle for C by using the supplement, and then subtract like the supplement of C and then subtracting by 180?
Well, what would happen?
Because that's what I did and I didn't get that. I got like 85.
Oh, okay, so you found all of these.
Yeah.
Then, no, find the supplement of
Only
this.
of one.
Yeah, the second one that you find. Yeah. Yeah, I get what you're saying. Now, do you guys understand how to solve for now the missing sides? You just use your law of sines. So you're going to find, we have side A and B, so you're going to find C over here, and then you're going to find the missing ones over here, just using law of sines. Long problem, yes? Nothing you guys can't handle. We're going to practice this a whole bunch. Yes, what's your question? Example, we did it was 200 when I added those together. So you're like, oh, it's more than 180. There can't be two triangles. But in this case, it's less than 180. So, ooh, they're joking us. Does that happen all the time? No. All right, now this is super easy. Area of a triangle. You guys know the area of a triangle is 1/2 base times height, correct? I like to write it as base times height divided by 2. That would be when our triangle is acute. We're going to talk about, or obtuse, we're going to talk about how to find the area of an oblique triangle when we don't know what the height is. We can't, they don't give it to us. We can't find it, okay? There's a little formula there. Now, all this is saying, guys, is you take two sides and the included angle. All right, do you see how you have B and C and then the sine of A? Here you have A and B and the sine of C. Here you have A and C and the sine of B. What they're telling you is that you can find, no matter what you're given, you need two sides and the very important information here, included. What does that mean? The one that's in the middle. They might give you two angles just to try and mess you up. Don't fall for it. Now it says 1/2 times this. You can also say divided by 2. But you take the two sides times the sine of the included angle and you divide by 2. This is how you find the area of an oblique triangle. It's the, yep, but it's the two sides. So you have like side A times B times the sine of C divided by 2. That's it. The two sides and the angle in the middle. So, do you guys see this? Look at this triangle. First thing I would do is say, do I have what I need? Do I have two sides? Yes. Do I have the angle in the middle? Yes. So now I can use this formula. So I would say area equals 52 times 90 times the sine of 102. It's the two sides times the sine of the angle in the middle. Now you can put a 1/2 in the front. I like to just say divided by 2. So in your calculators, what's 52 times 90 times the sine of 102? I'd hit enter, then hit divided by 2. What do y'all get? 2,288.87. And we're talking about meters squared. Whenever we have area, it's squared. Literally, guys, that's all that this problem is. That's it. Let's do another one. Let me just make up something. Ooh, trying to get tricky here. If you're finding the area of an oblique triangle, what do you need? You need two sides and what? The angle in the middle. So what two sides and angle would I use here, guys? 18 and 17. Do you see that? Don't just grab any random two sides. You need the two sides that have the angle in the middle. So you would say area equals 17 times 18 times the sine of 34 and divide all that by 2. Now, I just made this up, so. 85.56 meters squared. That's it. That is area of an oblique. You're going to have another area formula tomorrow called Heron's. It's not much different. All right, how do we feel? Lots of calculating? Okay, fine. So tomorrow, I don't know. Maybe we'll just work on Law of Sines tomorrow in class. You guys have lots of practice you can work on, and then we'll do on Wednesday Law of Cosines. That might be better.